Good afternoon, my YouTube viewers. It's Crystal here. I'm just here this afternoon because I wanted to make a video for you on how to carry out all of the descriptive statistical functions in Excel and one of them in Python as well. What I would recommend to do, because I'm just now starting to learn Python on Excel, what I would recommend to do is to use all of the functions in Excel that you can. And then if there is a function in Python that is not in Excel, then I would recommend to go ahead and use that function in Python that's not in Excel. And the reason why is because Python in Excel is a little bit hard to work with. It's just now being rolled out to the different versions of Excel in Excel 365, but it still has problems. For example, when you import your libraries, you have to import the libraries on the first spreadsheet of your workbook. And so you can see here that I've imported pandas, NumPy, Matplotlib, and Seaborn. And then you can see over here that I've imported SciPy, and from SciPy import stats. So I'm not sure that SciPy is going to work because I haven't been practicing with SciPy yet. If SciPy doesn't work, I'll let you go. But you've got certain libraries that are hardwired into Python with Excel or Excel with Python, and the other ones that are not automatically hardwired, you need to install them yourself, and that's going to be a little bit difficult. And so whenever I get to SciPy, that's when I'm going to have problems trying to get it working. But what you can do is you can go over here to initialization, and then what the initialization will do is it will tell you which libraries are automatically encoded, automatically hardwired into Python. The rest of them, you've got to install them yourselves and import them yourselves. So, as I said, the only one that I'm really worried about at the moment is SciPy. So, whenever I get SciPy working on Excel, I definitely will let you know. But what we're going to do is we're going to discuss descriptive statistics on this one page. And I've gone through all of the functions in Excel that govern descriptive statistics and one of the functions in Python that governs descriptive statistics. So we will talk about Excel first, and then after we've talked about Excel, then we will talk about Python. So the first thing we have is we've got our measurements of central tendency. So those are going to be the measurements at the center of your distribution. So the mean is the average of A2 to A51 of our random sample, and your random sample is a random number between 1 and 50, and it's going to be 50 times. So it's going to be A2 to A51, which we've got here. And the median is the number that's in the middle, So what you do is you sort your data, and then after you have sorted your data, then if there's an odd number of values in the array, you take the value in the center, and that's going to be your median. If it's an even number of values in the array, then what you do is you take the two values in the center and you average them, and that's going to be your median. So the next thing that we're going to cover is mode. It's going to be, that's going to be the most frequently occurring value in the array. And in this particular instance, the most frequently occurring value in the array is going to be 44. Now what I might do is I might do value counts, and then with Python, and then if you do value counts with Python, then you will see all of the numbers appearing in the array. Now we're going to cover the measure of dispersion, measurement of dispersion, and that is going to tell you the range or the values, the beginning values and ending values that you're going to be dealing with in your data set. So the minimum value is not a measure of dispersion, but I put the minimum value in there because you're going to have to use the minimum value when you get your range. And the same as the maximum value. The maximum value is not a value of dispersion, but you're going to need the maximum value when you get your range. And so we have the range. Your range is your maximum value minus your minimum value. Now we're going to talk about quartiles. In a range of data, you have 4 quartiles. So Q1, Q2, Q3, and then you have 3 you have a 4th quartile anyway. But Q1 is you're going to use the quartile function A2 to A51, and 1 indicates it's the 1st quartile. And then the 3rd quartile is exactly the same as the 1st quartile, except instead of a 1, you're going to say 3. And now we're going to do IQR, which is your interquartile range, and that's going to be Q3 minus Q1. We also have in Excel, we have a percentile, and in the percentile, you can just say what percentage you want. And so in this particular example, I said that I wanted a 30%. So at 30%, it gave me a value of 22.7. Now we're going to do the variation. And your variation is your variance. It's a measure of the variability. It assesses the average square difference between the data value and the mean. So you have a variance for your population and then a variance for your sample. So your population is the entire group, whereas the sample is a sample of that group. So you can see that the variance of the population is 165.2944, but the variance of the sample is 168.6677551. And it's the same with the standard deviation. The standard deviation is the square root of the variance. And then the standard deviation, it's expected that the vast majority of the data is going to fall within 3 standard deviations of the data frame or of the data set. So most of the data is going to be within 3 variations of the data set. So the standard deviation for the population is going to be 12.85, but the standard deviation for the sample is going to be 12.98, because you see you have different formulas for the population and the sample. We also have something called mean absolute deviation, and so this is easier to work with because it can be calculated by hand. But what you do with the mean absolute deviation is you have to calculate your absolute deviation, which is absolute deviation is A2 minus G2. And you notice that the G2 has dollar signs in it and your G2 is mean, but the fact that the G2 has dollar signs in it means that it is an absolute reference. So even if you move the formula, you move the cell down somewhere else, it's going to still maintain that reference. And so we do that for the 50 variables, for the 50 elements. And so after you've got your absolute deviation, let's see what it says. After you've got your absolute deviation, then what you want to do is you want to calculate the mean of that absolute deviation. So it's going to be the average of B2 to B51, and so it's going to be 11.2. So the mean is 30.16, but the mean absolute deviation is 11.2. And your standard deviation for a sample is 12, but your mean absolute deviation for the absolute deviation is 11.2. So that just gives you your mean absolute deviation, and it's a little bit different from standard deviation, but that's how they do it. That's how it's done. And then we've got some other statistical functions that are not in your measure of central tendency and measure of dispersion, which is your sum. And your sum is, and you add up all the values in the array, and you got 1508, and you do a count. So the count is you count all the values, and that's going to be 50. So you have the product of the values. And so what that is that's you're multiplying all of the values together. And you can see that that's a very large number. So you're not going to be using the product a lot. You've got something called a skew. So your data frame can be right skewed, left skewed, or zero skewed. So if it's right skewed, that means that the skew is going to be on the right side, and if it's left skewed, the skew is going to be on the left side, and if it's zero skewed, then it's going to be symmetrical. So you can see that this skew is negative 0.2, so that means that it's skewed on the left side a little bit. You also have something called kurtosis, which is the tail. And so the kurtosis tells you about the tail. And so I do know what skew is because you can look at the array and can see whether it's skewed or not. But I don't work a lot with kurtosis. But the kurtosis just tells you how fat the tail is. So after we've talked about all of these statistical measurements that are in Excel, what I wanted to do is I wanted to give you one that's actually in Python that's not in Excel. And as I said, what I would recommend you do is you use all the formulas in Excel that you can. And then the formulas in Excel that you can't use, then you can go ahead and use Python. So this is a relatively easy formula. We're taking the data frame or the array of data, and we're converting it to a data frame. So df equals XL, and then A1 to A51 is inside quotation marks, and headers equals true. And then I said describe equals df describe, and then I said describe, because basically what Python will do is it will show the very last block of code, the very last command in the block of code. So this is the describe function in Python. And so in the describe function in Python. You've got count is 50, mean is 30.16, std is 12.98722, min is 4, 25% is 20, 50% is 30.5, 75% is 42.75, and max is 50. So what I wanted to do here is I wanted to try value counts. So come over here. You can say so it's py, that lets you know that it's Python, and we're going to say df. I'm going to say vc equals df dot value counts, and then we say vc. That's short for value counts. And then what I do is I click on the little plus sign, and so when you click on the plus sign, it says that it's a series, and then it gives you a little square box, and I'm going to say array preview. It says it's busy, and then so basically these are your value counts, and so it's telling you, it's giving you a tuple, but it's not actually telling you the actual value. It's just and it says there's 5 of the value. So that is a problem with Python because it just says it's a tuple, but it doesn't say what the value is. But let's see, we can try this. Try Python string, see what happens. Doesn't look like it's doing much. So when we tried value counts, it didn't work the way I wanted it to work. I wanted it to show the actual values and the count of the number, which it hasn't done that. So that's a problem with Python. So Python in Excel is going to have a lot of issues that it needs to have worked out. So the describe function worked. That worked. But the value counts function hasn't worked the way I personally would have liked for it to have worked. And so that's going to be a problem that needs to be worked out. And that I did actually work on it yesterday, and I was quite frustrated yesterday when I was working on it because I couldn't get it to work the way I wanted it to. But what we can do is we can say maybe diagnostics, that it's supposed to actually Python preview. It's supposed to actually tell you what it is. It's supposed to tell you what it is, but obviously it's not doing that, which is something that I'm not really happy about. So the initialization isn't giving it to me. The diagnostics isn't giving it to me. So yeah, it's just not working. I'm sorry about that. If I ever do get it to work, because it's supposed to be able to give it to you on the right hand side, and if it gives you to you on the right hand side, then It's just not doing that. It's just not doing that. Okay, so I'm talking, and then what I did was I made a histogram of the data so you can see a histogram of the data. I'm also going to go ahead and make a box plot of the data. And the reason why I'm going to make a box plot of the data is because the box plot gives you your quartiles. So we'll go ahead and do a box plot. You go Insert, Recommended Charts, Box and Whisker. So this is your box and whisker chart. So we've got a histogram and a box and whisker chart. And that's it really. So I'm sorry that I couldn't get the value counts to work the way that I wanted it to work. It gives you a tuple, but it's giving you a tuple, but it's not giving you anything else, and it's very disappointing. And so until Excel clears up these problems, I'm not sure that Python is going to be beneficial. So because it's not going to be beneficial because it's just saying tuple, and we don't want it to say tuple, do we? Or we could say so this Python here, it means that there's a problem with the code. So I have to work on that some more, but it's just showing you that there's a problem with the code, that it's not, the code isn't running up the way it's supposed to run up. And it's a shame, really. It's a shame. And until this problem's cleared up, I don't think that Python's going to be very successful. So I do think that you should use everything Excel that you can, and if there's a formula in Excel that you don't have in Excel but you have it in Python, then try that out. But you can see I've tried two formulas. I've tried the describe, and that worked out okay, and I tried the value count, but it's not giving me the numbers. It's not giving me the numbers. So what good is it if it's not giving me the numbers? But I've been talking for close to 25 minutes, so I'm going to go ahead and conclude this video. Thank you so much for watching my video. If you like it, please like and subscribe, and I look forward to making more videos about technological ideas for you in the future.